Okay, let's take a look at this Go now. This is on page 41 and page 42, and they're giving us two lines to compare, and it says to determine which function will be increasing faster when x is very large. And so let's just go over a couple of things first. First, if one of the lines is steeper than the other, it means it's increasing faster. So if you happen to know what a steeper line looks like, that works. Also, if the absolute value of the slope is greater, then that means it's steeper. So it is increasing faster if its absolute value is greater. Okay, so let's go take a peek now at these examples. So here we've got this line, and we're going to just look from corner to corner. So for example, like for sure it's this corner, up 1, 2, 3 over 2, 1, 2, 3. Ooh, this one's hard to tell. No, I wouldn't even say that one's on the line. Let's look at this one down here. So this would be up 1, 2, 3, 4, 5 over 3. Okay, that looks like they might actually be dots. So we're looking at this first function, and we're saying that the slope is 5/3. And now we're going to look at that other function, which technically looks steeper. So hopefully that one shows us a greater number. So again, we're going to try to find a corner and then another corner. I'd say that guy right there. Sorry, my dog's drinking water right next to me. 1, 2, 3, 4, 5, 6, 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1 would occur off the graph. So the second graph or function has a slope of 7. So which one is greater, a slope of 7 or a slope of 5/3? And so we would say that this line is increasing faster. And so we're going to go with the purple function, or however you want to do that, highlight it. Okay, looking at the next one, we've got two different lines. We've got one that's pretty much horizontal. That means that the slope is 0. And then we've got one where it's more of a slant. So let's go count that slope. And so that slope goes up 1 over 1, 2, 3, 4, 5, 6, 7. So that's up 1 over 7. So which one has the greater slope? We're going to say that the red line is increasing faster because it actually has a larger slope of 1/7. Okay, looking at this next one, we've now got names for the functions m of x and n of x. So again, if you're getting good at this whole steeper versus not as steep, this one right here is the steeper line, but let's look at the actual slopes. So the slope on this guy, if I start on this corner, actually let me use a different color, hang on. If I start on this corner here and I count to this corner here, it's up 2, 1, 2, oh, looks like actually we've got an up 1 over 2 slope. And then the other line, which is going up not as fast, also has a corner dot here. We'd say up 1 over 1, 2, 3, 4, 5, 6. So the other one is a slope of 1/6. So what's greater, 1/2 or 1/6? What's steeper? And we can see that this one right here, the blue one, would be our function that's increasing faster. All right, looking at this one, we've got this line that's kind of going at a shallower pace, and this one that looks like it's going up a little bit faster. Let's go count those slopes from this corner to this corner would be up 1 over 3 for the red line. And then the pink line, up 1 over 1, 2, 3, 4. So what's greater, a third or a fourth? And so we were right, that one is steeper. The red line with the 1/3 slope is increasing faster. Okay, now we get into exponential functions. Which one is going to be going faster for larger values of x? So picture how this one starts going up, 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 up faster than this one over here. So we would say f, oops, wrong color, red. We would say f of x is increasing faster this time, going up steeper, going up sooner, etc. All right, let's look at the next one. See how this one's going up already that fast, and this one's going up at a little slower. So we again would say this time that p of x is increasing faster. And here we've got a line and a curve, but we see that the curve starts going way up, way fast, and the line's sort of moseying on. Sorry, I meant to grab purple. Sort of moseying on there. So here it's showing the true nature that a curve or an exponential function, r of x, is increasing faster than the line s of x. And this is really a Math 1 topic. In Math 1, you're supposed to leave Math 1 with a sense of the fact that exponential functions will grow at a faster rate than linear functions. And so if you have that general assumption, then you got the standard that Math 1 was trying to teach you. If not, well, now you know. In Math 1, we were supposed to know that exponential functions are always going to grow faster at a faster rate than a linear function. Okay, examine the graph from 0 to 1. Which graph do you think is growing faster? So now we're looking at intervals. So it's telling us specifically to look right here from 0 to 1. If I just look at that little section, do you see how this line has a slope of 1, 2, 3, 4 over 1.5? So up 4 over 1.5, and it's pretty steep. And then if I look at the little section here, it's only up to here. Hang on a second. I counted too far. From this right here, this little section right here, from 0 to 1, from here to here, we can see that this goes up 3 over 1, more or less. And then the curve, it goes up 2 over 1. So the line in just this little interval goes up 3 over 1, but the curve in just that little interval is only up 2 over 1. So technically, the line had a faster, it was increasing faster than the curve in just that interval. It's like the line is constantly going its rate. The curve starts out slower and then starts picking up. So now look at the graph of the line from 2 to 3. So check this out. So from 2 to 3, now we're talking this section here. So we can see that now the line is going sort of just up like that, but the curve is like taking off. And the curve surpasses the line at that point. So we would now say that the curve is now increasing or growing faster. than the line on the interval 2 to 3. So something to keep in mind is that the curve does start out slower and then pick up speed. But in general, for large values of x, we know that curve is really going to see some increased growth compared to the line.